Okay, this is a video for the E over M experiment for the Physics 270 lab here at the University of Scranton. This is Mulhall coming at you. Majid's behind the camera. And there's Chunkail in the corner. So I'm going to guide you through the wiring and the setup and how to take data with this experiment, with this apparatus. So Majid, if you come around first, we'll just see. The basic idea is this. There's three signals, so to speak, that we're going to control. We're going to have a current going through these Helmholtz coils. They're going to generate a uniform magnetic field inside the ball, and that's going to deflect the electrons into a circle. We're going to have a heater current. So this says heater, 6.3 volts, 1 amp. This is wired directly into here. And what that's going to do is it's going to heat up a little piece of wire here. And when you have a wire that's really hot, if you put a large voltage near it, electrons will be pulled off. If it's a large positive voltage, the electrons will be pulled towards it. That's called an accelerating voltage, and it's the third thing we're going to control. This knob here controls an accelerating voltage that we're going to monitor with this. We're going to monitor the Helmholtz coil's current with this guy. You'll notice that the ammeter, which we're measuring current with, is in series. The voltmeter is in parallel. That's always the way it's going to be. So let's go. First we're going to turn on this guy, and you're going to come across this quite a bit in the physics labs. You're going to have a power supply that's got two knobs. It can be constant voltage or constant current. So what you could say, I'm just going to have this at constant 15 volts by limiting the current, making the current real small, or you could say I'm going to have this we'll say a constant 2 amps by making the voltage big. It's a little bit counterintuitive, but this is how these things work. So we've just cranked up, and as I turn this up, I can see that the current is increasing, so there's a bigger and bigger magnetic field here. Okay, let's turn this guy on. And look, we can see, if you see the back of my hand here, you can see a little orange glow. You can see it in there. That's the hot filament. Now I'm going to turn on the high voltage. So far all I've done is hit this switch, I can wiggle this knob, I hit that switch, and then I'm only adjusting this knob here. This is telling me I have an accelerating voltage of 384 volts. So the electrons are coming off the hot plate and they're bombing down, and they're going to be turned by this magnetic field. So Majid, if you turn around the side, I'm going to show you how we do it. Okay, so I'm turning up the current, and can you see a ring, Majid?
Yes. Okay,
so that ring is I've got 1.7 amps here, I'll take a note of that. The accelerating voltage is 383 volts, and if I turn it up higher, the ring should get smaller, because now I've turned it up to 2.47 amps going through the Helmholtz coils. I bet you the ring got smaller.
Right.
Now I'm going to turn up the voltage, and I bet you the ring's going to get bigger. Did the ring get bigger?
Right.
Of course the ring got bigger. I turned up the voltage, the electrons are going fast. You don't have to be the great physicist Dirac to figure that out. The bigger the accelerating voltage, the harder it is to bend them. I'm going to turn down the current, and the ring is getting bigger, and now it's probably gone.
Right.
Okay. That's all you need to know to take data with this thing. Thank you very much.